Over eclipses and tides. Has more to do with the moon than the sun, but that's how it ties in this case. Alright, so an umbra is the central, darker part of a shadow where light is totally blocked. The penumbra is the lighter part of the shadow where light is partially blocked. So pen means before. In this case, this is before the umbra. That's the penumbra. A solar eclipse is when the moon's shadow appears on the Earth's surface. A lunar eclipse is when the moon moves into the Earth's shadow. We'll talk about those and we'll see pictures of what those look like more later on, so don't worry too much about visualizing those right now. And the tide is the daily rise and fall of the sea level. Alright, so shadows. Again, umbra is where the light is blocked by an object. In this case, you cannot see the light source at all. So if you're in the umbra is in a specific area where the shadow is, and in that case, you can't see the light source at all. The penumbra is the lighter part of the shadow where light is partially blocked. You can see only part of the light source in this case. So the root pen means before, so before the umbra. Here's what we're talking about. In this case, we have the sun shining light towards Earth. The umbra is this dark shadow. Anything that's still shaded, anything that's still cast, or anything that the Earth still casts a shadow on, is in the penumbra, so before the umbra. So the umbra is the very, very dark part. The penumbra is the part that's a little bit lighter. It's receiving some light, but it's much less than otherwise. Alright, so solar eclipses occur when the moon is lined up directly between the Earth and the sun. So it goes in this order: sun, moon, Earth. This happens during a new moon phase. The umbra from the moon moves across the Earth's surface. Total solar eclipse is only seen from within the umbra. So there's only, when the moon moves in front of the Earth, it doesn't cover, the entire Earth's not cast in the shadow of the moon. Only a certain spot is. So you have to be in a certain position to see when you have a solar eclipse. It can be seen from more positions, but to see the full solar eclipse, you need to be in the umbra, which is just one spot on the Earth. It lasts no longer than 7 minutes because it moves relatively quickly. Partial solar eclipses occur when you are in the area of the penumbra. Here the moon only blocks out part of the sun. Solar eclipses don't happen every month because the Earth's orbit or orbital plane is tilted slightly compared to the Earth's. So they kind of cross essentially. The Earth is either above or below the shaded or the shadow formed by the moon. So this is what we're talking about with the sun, the moon in between, and the moon between the Earth. So again, you see the umbra is the dark spot here, and it's just on one spot on the Earth. Here we have the penumbra, which covers much more area. But this, in this one spot, would be the place where you'd say you're experiencing actual solar eclipse. Here are some pictures of what the solar eclipse would look like. You have the moon. It just looks like a large shadow in front of the sun in this case. So a lunar eclipse occurs when the moon moves into the Earth's shadow. So it's sun, Earth, moon is the order. Only occur during a full moon phase. Can be seen anywhere on the side of the moon that is facing the moon. A total lunar eclipse is when the entire moon is in the Earth's umbra. This causes the Earth's atmosphere to reflect some light onto the umbra. This reflected light appears red, causing the moon to be reddish. Partial lunar eclipse, only part of the moon is in the Earth's umbra, causes part of the moon to look darker, not the entire moon. So, in this case, again, we have sun, Earth, moon, with the moon being behind it. Notice how much larger the Earth's umbra is. The penumbra will extend way past. There's a reason that it looks reddish, and that has more to do with what happens when light passes through the atmosphere. It's the same reason that clouds get reddish when it starts to get towards sunset. But that's what causes the moon to look red in this case. And here we have some examples of what that would look like. Tides are caused by the gravitational forces of the moon and the sun. The ocean water rises and falls 2 times a day. It's caused by the moon. The moon's effect on tides. The moon's gravity pulls water upwards or towards the moon on one side of the earth that the moon is on. This leads to a high tide. In this case, the opposite side will have high tides as well. I apologize about the spelling errors. I must have forgot to spell check it. The sides and right angles to the moon is where low tide is. And again, we'll see pictures of these because as good as the words are, the pictures help a lot in these situations. So the sun's effect on tides. The sun is so far away it only has half the effect as the moon's gravity. Even though the moon's really small, it's much closer than the sun, so the moon has more of a pull. Spring tides occur when the earth, moon, and sun are lined up. This corresponds with full and new moons. The moon and the sun's gravity combine, causing it to be the highest tides and lowest tides. Neap tides is when the earth, moon, and sun make a right angle. The sun's effect reduces the moon's effect because they are pulling in different directions. This corresponds with the first and third quarters. So, in this case, we have the moon, earth, and sun all lined up. Order is not really doesn't matter too much. You could have the moon right here, as long as they're all pulling the same way. So we have high tide, where we're essentially stretching all the water out in this case. So we have high tide in line with the moon and sun, and low tide where they are not lined up. So here we have, again, we've seen this before, where we have high tide and low tide. The new one we haven't seen is going to be the neap tide is what this is called, when they make a right angle. So now we have low tide, okay, so this would be spring tide when they're all lined up. This would be neap tide when they're not. So now we have low tide where the sun is and high tide where the moon is, but you can see how the light blue is spread out a little more here. There's a thicker layer around it. Here we have more on either side, but not so much up here. That's because the moon and the sun are pulling against each other, not pulling with each other now. So it's kind of more spread out. So your lows are higher and your highs are lower, as opposed to here your lows are lower and your highs are higher. And that will do it for this lesson.